going to talk about absolute value functions, domain of a function, those things. Why is this marker was brand new? Somebody left the cap.
Oh yeah.
Yeah, why do we have to come into that?
No.
Only the sophomore.
Okay. Absolute value function. Remember that absolute value, the parent function is f of x equals the absolute value of x. When you graph that, when you input 1, you get 1 out. When you input -1, you get -1 out. And absolute value functions are always graphed as a V. The domain of the parent function is -infinity to positive infinity for x. The range of the function, okay, it does not go below 0. So the range is 0 to infinity. It includes 0, does not go below it. Your intercept is 0, 0 in this case. The only thing that crosses the x-axis or touches the x-axis. Your decreasing and your increasing factors. You're going to have to be able to label all this stuff from here on out. Decreasing and increasing. Your decreasing factor is from -infinity to 0. It's decreasing as I go that way. And your increasing factor is 0 to positive. Okay? So when you are doing absolute value, when you are doing functions now, you're going to have to list the domain, the range, the intercept, the decrease, and the increase. It's decreasing because it gets negative the more numbers I put in this way. It's increasing as I go this way because my numbers become positive. My domain is -infinity to positive infinity because that's how far it travels on the x-axis. The range is how far it travels on the y-axis. It stops at 0, but it continues up forever. So you're going to have to write everything in interval notation. The other types of graphs that we are going to do are piecewise functions. Piecewise, yes. And it's where you have more than one function being graphed at once. So f of x equals x squared plus 1, x is less than 0, and x minus 1, and x is greater than or equal to 0. These are considered piecewise functions. When you graph it, you're going to get two different styles of graphs on one graph in your graphing calculator. When you plug these in, this is how you plug it in your graphing calculator. You're going to put where that y1 is, okay? You're going to put parentheses, x squared plus 1. Then you are going to end those parentheses, and you're going to put another set of parentheses where it says x is less than 0. To get the less than button on your graphing calculator, you have to press okay, so when you put this into your graphing calculator, you go to the first spot, you put parentheses, x squared plus 1 in parentheses. Then I put parentheses x. If I want the button less than, you have to press second and the math button so that it takes you to test. Second math will get you that right there. If you press second math, you're going to get the options of all the less than, greater than, all those things. And then you put 0 and then you in parentheses. In your second line, you're going to drop down and put parentheses x minus 1 and then parentheses x is greater than or equal to 0. If you don't put this parameter in here, it's going to give you a full graph and not cut it off. A piecewise function is cut off at the particular limits. So you have to make sure that you put both of those into your graphing calculator. If you don't put these parameters in there, then it's just going to give you a larger graph, and it's not going to cut it off where you need it cut off at. That it does that for you? Yeah.
So we hit graph now?
What?
We hit graph?
Yep, and then if you hit graph, if your graph is in standard function, like if your window is in standard function, -10, 10, 1,
I think mine's
Negative
at a place.
-10, 10, 1, it should work.
Wait, so how do you get X?
How do you get what?
Like the X.
The X button?
Yeah.
If you go next to that green button that says alpha, do you see the first thing listed is X on that next button?
Yeah.
That's how you
Okay.
get X.
That's what I thought. I'm gonna make sure.
Okay, so then this makes graphing much easier for us if we can graph it on a graphing calculator the way we want. Yes?
Yes.
Okay. And then that means on your tests and quizzes, you shouldn't mess up the graphing if you know how to use the graphing calculator.
Have you ran
What's your window set to? Where's your window sound set to? Perfect. Okay, so your graphing window needs to be checked. Now, domain of a function. The domain of a function is the set of all real numbers for which the expression is defined. So if you have the function f of x equals 1 over x squared minus 4. The way to find this domain is that you have to take x squared minus 4, set it equal to 0, and solve for x. Take the square root, and x would equal plus or minus 2. Because when you take the square root of something, you have a positive and a negative input. These two values are excluded from the domain because division by 0 is undefined. Okay, so what that means is I can write this one up 2 ways. Domain is all real numbers except x cannot equal plus or minus 2. Or you could write it in interval notation, which they're going to ask you to do, where it says negative infinity to negative 2, and then united with negative 1. Nope, let me think about this. Yeah, negative 1 to 1, and then united with 2 to infinity. When you put parentheses, it does not include this number. It means union, which means it includes all of these sets. Okay? That's how you would write it in interval notation.
So if you write it with that the U, is it wrong? Isn't it the same thing without the U? Can't you just like, right?
This is just the proper way to write it. But yes, I would know what you mean. Okay? If you have the square root function, bringing back lots of things from last year. Square root function. Remember that the square root function, as its parent form, is f of x equals the square root of x. And your graph looks like this. Starts at 0, 0. If you take the square root of 1, you get 1. You take the square root of 4, you get 2, correct? So your parent function of this looks like that. Your domain of this, what is my domain of this graph? How far does it travel on the x-axis? It does go to positive infinity. What about the other side? What about this side? 0. It includes 0. 0 to infinity. What is your range of this graph? Your y-axis, what is your range? How low and how high does it go? 0 to what? To infinity also. Your domain, your range, we need intercepts. What are your intercepts? 0, 0 is parent function. What is your decreasing and increasing? Where does it decrease? Where does it increase? Does it decrease? Does it increase? Yes. Does it decrease? What? Nope, it doesn't, so I don't have that one. Does it increase? Yes. Where's it start at and where's it going to? 0, where's it going to? To infinity. So I have 0, infinity as my increase factor. So you're going to have to be able to label all of these things in every graph that you see from here on out. Okay. The last thing we need to talk about is the difference of quotients. And you saw this on your quiz because I put this on there as extra credit just to see if anyone would attempt it. Yeah. And some people we're on the right track. Difference of quotients says f of my function x minus h minus f of x, my function f of x, over h, where h cannot equal 0. I never took attendance, I'm gonna get in trouble. Okay. So this is your functions, okay? And we are going to use that to solve for other piecewise functions or for other quotient functions that they give us. So it says f of x equals x squared minus 4x plus 7. And it says find this. Okay? So you have to physically plug in this whole equation every time there's an x. Okay? Every time there's an x. That becomes a little bit difficult, and we're going to talk about why that becomes a little bit difficult in a second. So here's what ends up happening. You should plug in f equals, okay, it should say x plus h squared minus 4, okay, because I'm plugging where this is, I'm plugging that equation. So minus 4, okay, and then there's an x again, so I'm plugging in the x plus h, okay, plus 7. But then I have to plug in minus the function itself, x squared minus 4x plus 7. All over h. So I am plugging in anywhere there is an x, I am plugging in this part. Anywhere there's a function, I'm plugging in the whole equation, which makes it a little bit more complicated. Okay, from there, if I FOIL this out, you get x squared plus 2xh plus h squared, okay? Because I can do that in my head. Then you get minus 4x minus 4h, okay? And then you have plus 7, and then you have minus x squared plus 4x minus 7 all over h. From there, we combine like terms. My x squareds cancel. I have 2xh, so I can bring that down, I know that, okay. I have just an h squared, okay. I have negative 4x, positive 4x, they cancel. I have negative 4h and my 7's cancel, right? So now I have an equation that looks like that. What do you think I have to do from this step? Can I take anything out of everything? An h. So if I take an h out, I get h plus 2x minus 4 over h. What happens from there? H's cancel, and I get h plus 2x minus 4, where h cannot equal 0 as my final solution. And that's how you have to go about finding the difference of quotients. A lot of stuff is going to cancel out during that. Okay, that is what we're looking at today. Finding functions, function notation, writing things in function notation, finding domains, ranges, intercepts, decreasing and increasing of everything. When you have piecewise functions, make sure you plug them into your calculator correctly. Parentheses, and then I do parentheses and define these that less than or equal to 2 signs and things like that. You're using second math. Once you do that, make sure your viewing window is in standard form for most of these. If it needs to be in a different form, we can look over that. But standard form, negative 10, 10, 1, negative 10, 10, 1. You should be able to graph this and do everything tonight.